Hello, hello. Thank you for, yeah, I don't know what to say. Thank you for being here. Thank you for watching, to all of you on YouTube. Probably nobody on LinkedIn yet, maybe later. Let's get to work. Last time I worked on this PMIC circuit, and what needs to be done is this buck converter. So I have to make some space for it. Yeah, this below the PMIC. So it's the, I think I can remember that this is, yes, this device is not in my library. Let's try snap EDA. To save some time. Yes, that's good. They seem to have, yes, this is the ESOP standard, but probably, yes. But yes, the symbol looks good. Oh, not a big deal. Yeah, I will import the symbol and modify it a little. Yes, it's well available. Here is the data sheet. Yeah, this is the, no, this is not ESOP, this is VFD FPN, small package. Yes. So I will download everything they have, including the 3D model. I don't know if the 3D model is part of the archive. I hope so. Oh. Yes, here is the step file. The package is this. So I will rename the step file to something more footprint-like, because the part number of the IC is not a good name for the for the 3D model, as well the footprint. Yeah, and this can stay as is. KiCad. Okay, simulator. New project specific library. Downloads. KiCad pool. Yes, and the name is this. This is our symbol. The symbol looked good on the, yeah, I hate this mess. Yeah, maybe it's not a mess, but to me it is. To me it is a mess. Okay, description MF is nothing. So all the scrap will go away. Data sheet is here. The next is manufacturer's order code, which is here. Next is supplier, which is DigiKey or Mouser, and JLCPCB code, that's important. Oh, yes. Oh, yeah, they have some for the same price as at DigiKey. Slightly cheaper. Okay. So this is the JLC code. Keywords is buck, switching regulator IC, that's buck. Positive adjustable 0.8 is the feedback voltage. 2.8 to 5.5. It's very important. 2.8 to 5.5. 3 amp is the current. The feedback will be in the symbol. One output is not important. 3A. It is exposed FET. Okay, of course. Okay, this description worked for me pretty well, and now I have to customize this. There is like 10 pads and or pins, and it's a number that, yeah, if I select it and copied the symbol and paste it to the text editor, I would be able to make the changes globally. So all pins by one find replace operation. But yeah, 10 is like the number on the edge. Yeah, like even, like, yeah. If there are 20 pads, I would definitely do it automatically. But 10 is like, yeah. As you saw, I was finished in, I don't know, half a minute. So, yeah. It's the comparable time when opening the text editor and orienting with it, looking for the spot where it needs to be changed. Okay, 2 input voltages. Okay, this can work. Oh, 2.25. Okay. Most importantly, I have to copy it into my library because I am still in the project-specific library, which is not the target destination. Here it is, my library. Okay, footprint. This needs to be corrected. So preferences. Yeah, that's some old library from our previous run. Yeah, this is the library. The footprint, I have it in my clipboard here. Yes, this is it. And just for the sake, yeah, no similar package in the footprint library of KiCad. It means that I am not going to duplicate this, which is something I really don't want to. Yeah, 0.8 is like the minimal size, well readable. Yeah, 0.7 is like good as well, but I will keep, yeah. The dot near the pin 1 is great, but not in the footprint. Why? Because I don't know why. Anywhere it is, it always interfere with some vias. I don't know why. So I don't put it into footprints, but in the post process, like in the, how to say, yeah, in the cosmetic job of the PCB, I add all pin 1 marks. Yeah, you would say, okay, if you had this dot in the footprint, you wouldn't be able to do it. Yeah, I agree. But as I said, it always interferes with some vias, with some footprints, with some pads. I don't know why. It's like Murphy's law. Get back to this 3D model. Nothing yet, but we have our file. Here is the step, and my library is here with 3D models. Copied. Where are you? Here. This is the step. VFD. Okay, I'm expecting KiCad will crash, but nobody is perfect. I don't know. I can issue some, I don't know how to say, some application for a change to KiCad designers. They do marvelous job working on KiCad, but here I'm waiting for years for the search field. Yeah, when I type a few letters from the file name, it helps me navigate, because as you can see, there are hundreds of files and I have to do it all the time like a monkey. I don't know. It seems that nobody works on the libraries, but engineers do. Okay. Good. Lovely. Okay, so our footprint is finished. Specific library can go away. So VFD, we have to assign this. Yeah, something like this, filter. Yeah, in symbols, we have filters. In footprints, we have nothing. I don't know why. I really don't know why. Yeah, almost the same. So we have 10 micro and 1 micro. I suppose the switching node, not the switching input, has the bigger one. Let's check it. Yeah, well, important thing, as I said, the 0.8 to the yeah, this is something I use all the time. ST1, where are you? ST1 I can see that I have a similar one in my library in 𝗶𝗶𝗀𝗶𝗶. So here, yes, exactly. That's what I love. Visual information always present in the schematic. Yeah, that's what we need. So I'm looking for a recommendations, calculations, formulas tables describing what's the minimal capacity at each input voltage port. Input capacitor selection, yes. Yeah. Okay, so input switch 10 micro. Okay, so it was X5R. I will use probably 0805 because X5R is, it's like they say 10, yes. Yeah, it's a similar one, but XR7, yeah, much better. Much better, okay. Hello. Hello. I'm working. One micro in, where is the footprint? Here, 0402. It's too small. Already placed, yeah. Oh, you are lovely, but I'm working now. Do I? Yeah, I can remember. That one of them is not placed. Yeah, the bottom one. Okay, so I will do it similarly. Yeah, it goes here. Am I correct? Yes, I am. Okay, this should be somewhere here, and this value a little bit higher. Okay, yeah, I ended up with the similar circuit, yeah, but the switching is to 10 micro and input is 1 micro. I hope it's understandable. Yeah, I hope so. Power good. Okay, the inductor. The inductor is this one. Ah, it looks. What was this? No, it was 680. It's worth, so should be well available. Oh yeah, this one, semi-shielded. Yes, drum. Almost 4 amps in the saturation. No, yes. Saturation current 2.2. Rated current is 3.8, but it's driven by the ohmic, the DC resistance than, or the thickness, yeah, the diameter of the wire than saturation current, because if you are going over saturation current, the inductor is not working as inductor anymore. So the maximum current is really 2.2. So what's the size? 4 times 4. Yes, 4. So I will check my library because I have not a plenty, but some. 2.2, 2.2. Here is some bigger one. 4. No, this is actually a better one by Coilcraft, shielded. I think I can use this one because its resistance is DC resistance is here, almost the same. The saturation current is higher, slightly, and yes, I will use this one. Anytime I can use my library in foreign or new designs. It makes me super happy. Now, 3.3, let's get some quick math. 0.8. Yeah, I'm opening my spreadsheet with this 0.8. They say 75K and 24K. 3.3 exactly. It works. Okay, so I can close this to save some memory because the streaming is always hungry. Yeah, I suppose they have 0402. Yes. Yes, I have plenty of such such resistors, but not in my library probably. But I understand that the 3 times 3 is the IC size, so I understand that. Yeah, it's not Yageo, and you know about my Yageo. And moreover, it's 5%, so it's a crap. %, 1%, this one. And let's go for my Yageo. Oh, safe lingness. No. I want to copy clean link. This is data sheet, part number, JLC code, and we are done. Okay, and along with the I have this RK, it's Murat, no, Koa. I really don't want to create another library item. It's quite expensive. The same price. Okay, I will keep my core, but still it needs to be done. %. What's wrong with these resistors? 24K is like pretty normal value, isn't it? $24K, 1%. Where is package here? 0402 in stock. Yeah, this one. I don't know why. Didn't find. No why. Yeah, and yeah. Here is the. I want the clean value. Power good is here, but just for the sake of EMC probably, because where is power good? Here. They have 10K. Enable always 0, always at input voltage. Yeah, and here is the. Yeah. Enable. We will control the enable, but I don't know why they use so small resistor. This makes more sense to me. I'm going to add the blocking capacitor at the, or let's say RF capacitor to near the upper resistor divider, and I need to find the CPCB code, which is 10 pico at 50 volt and P0. This Samsung works for me. Okay, now some output capacitors. They have two 22 micros, awful material in 0603. I will use 0805, not this. Output is 2.3, so yes, this one. This one. Even this one would work. What's this? What's the material? It will be a crap because 22 micro in 0603 is X6S, which is slightly better than they have, but I will use 0805. This is X5R. This is X5R. So definitely not better. Okay, I will use it, but I don't know to create. I don't want to create another symbol, but we definitely can have a better capacitor. Definitely. $10 volts. Yeah. For instance, this. Yeah, for even better price. 10 volts. What's their original? 6.3, yes. Yeah. Okay, I will use this one. I'm not happy. So this is our buck that is controlled from the PMIC. PMIC. What did I do? No, I want text. Oh, okay. PMIC and resistors and yeah, LEDs. LED, yellow, probably not a big deal. What's their size? 0603, yeah. Green, orange, yellow. Yellow is good, but we need to add GLC PCB code. Ooh, yeah, there is plenty of LEDs at GLC PCB, and it's always a pain to find it. So luckily I have used this one before for some customer probably wanting to, yeah, you understand. Here, 1K, no, 1K5, if they say. This one, yeah, with some obvious library work because it's missing GLC PCB code and because it's not Miyageo. Okay, so let's use our clever, okay, not 1K, 1K5. Okay, Miyageo RL 04, no, can be 1%, and we want 1K5. This one. Yes. Lovely. Lovely. Okay, so we have LED, we have resistors, and we have everything we need. I will keep this. I will keep this here because for our following hardware review, and we need to work on this power block for the MPU. Yes, this power MPU needs to be imported. Where is our, here, imported, and it's what, it's in what sheet? Power MPU here. Power MPU is called Power MPU. Here. I was blind. Perfect. This is our thing. Thank you. Thank you. Okay. So we have, basically they have the pure power block, and I don't know if we can separate all the power stuff because we have slightly different symbols. Yeah, because I'm lazy. MP already, yes, and we need here this one. This is ports, this is memory, and this is power, yes. This is our power. Okay, I will use the same number of components here because VDD core here, and they have 1 micro in a 04 probably. No, 0201. Oh, this is. Yeah. Thank you, but I have some delay after you enter the comment. So please, if possible, what do you mean by 1K? Do you think the LED resistor or some different component? Please tell me. I will be more. I will be waiting for your comment because, as I said, there is slight delay and I didn't notice it at the correct time. So 0201. It's painful. It's painful. Oh. All of them. It's not correct to use such components. It's not correct. It's not. It shouldn't be legal. It seems that a lot of people use them because 3.5 million such. No, it's not possible. It's not possible to manufacture such a board. I won't be able to solder it because no. I fully understand these caps are on the bottom side of the PCB. Where are the Gerber's manufacturing? Here. C120, 112. 112, yeah, this one. Okay. I have a similar one already in my database. Yeah. I will use this one because it's the same shit. Oh, pardon my language. 10 volts, 16. Yes. Yeah, it ends every time the same. It's quicker to copy one instead of modify all occurrences. Hello, good morning, afternoon. VDD core is VDD core. I will copy all of my labels, even though I don't think I need all of them, but just to be there. Yes. Okay, VDD core. Now VDD CPU, the same. The same. So this way, but here is CPU. Okay, what else? VDD, the same. Oh shit. VDD IO to VDD 1G1 here. How many of them? 3. Okay, so one less. No, one less. One few. Few or fewer? One fewer. One few. No, fewer. Because it's a second stage, yes. Probably. VDD IO. Here is nice. VDD CSI. 1 nano. 100 nanofarads from VDD core. It's 0102. This. What's what 6.3? Rather the Murata. Yeah, the part number is already there. Now this VDD IO. Yeah, here must be a core. No, CPU. Core. Now the VDD IO 123. 1233. I don't know why. Here, 3, it's correct. So it's tricky. 1 and 2 3s goes to VDD-IO. Only 2 caps. So 1 and 3s. I have to make some room. So 1 and 3s. Two caps. More space. 2 caps to VDD-IO. And and VDD2, VDD02, the same to VDD-A 1.8. Okay, so I have to place it here. And the voltage is this one. No, this one. Yes. What else? VDD, Q, DDR. This block of 4. Same, VDD2, DDR. So the same. But connected to VDD2 DDR. Yeah, the voltage that I suppose I won't need. And C, I need. I do. VDD3 USB. That's 100 nano, 0 ohm, and VDD3 USB. So something like this, but with 0 ohm resistor. I'm using 0402 because I'm not able to solder the 0201. I once worked on a miniature design with 010 on 0201 resistors and capacitors, and it was such a pain. So I said to myself that day, it was last time I am using such small components, only 0402 and higher and bigger, because it's not possible to manually solder it. So we have VDD-A, ADC, this will be 02 and 02, of course. The same Murata, probably I have some. Yeah, these 0201 capacitors in my library is from that day, from that project. Yeah, I don't have such. There was only a few of them. So that's 2.2 micro 10 volts. Okay, this is the one. Yes. The one. And the voltage is, I'm losing 10 volts. And the GLC is 10 volts as well? Yeah, it's the same. Yeah, of course, it's the same part number. Okay. Just double checking, 106. Yes. Okay. So we have VDD ADC. Yeah, there will be a crowded area here. No, I wanted to do this. And the input, no, here. And the input voltage is VDD A1.A. Where are you? Here. Okay, what else? We have AON. AON is 100 to VDD AON. Okay, CSI 1 micro, the same 100 VDD 1.8. So like this one. Yes. USB 1.8 USB here, the same. I have to start saving space because otherwise I'm in a big trouble. VDD, DDR, the same. PLL1 are both connected together, same. Okay, so we are here. Lovely. So the right side is done. What about the left side? Grounds, VSS on, everything to the ground. So my favorite repeat last action. So VBAT is this. I think I have this one. This is Schottky or not? I think it's a regular. No, it's Schottky. but 54. Yes. No, this one. Cathode, common cathode, yes. Oh, yes. This is the, yeah, well, finally a bigger one. Okay, so 𝗲𝗏 is a junction of two voltages I need to save space, so I will do it this way. And the voltages are VDDIO from, yeah, through the 0 ohm resistor. Okay, 0 ohm. And a 2.2, yeah, with 20 ohms and some header. Okay, I don't know. It's probably a simulation of battery on the VDDIO, and this is the battery input. Okay. It's not Yageo, but it has GLC PCB code, so yeah, I will change it, because otherwise the transition to Yageos and other high quality manufacturers would take too many times, too long. Too many time is a really stupid sentence. I'm sorry for it. So let's check what's already there. Yeah, the GLC PCB code is correct, but I want yes. This this one. Okay. VREF minus plus. Minus is ground. Plus is zero two from VDD 1.8. It's a 1 micro. Okay, so let's copy this. And this. No, this. Is the correct? Yes, and the last one is VDD8, VO8 cap. It's 4 micro 7 to ground. 4 micro 7. Okay. Okay, I'm going to take a 1 minute break, and you know what I'm going to do. If you want to support me, I created 2 courses: KiCad for makers, KiCad for beginners. Essentials in the beginners, advanced stuff in the makers. If you enroll the course, you will receive within 30 days coupon for the free PCB-A manufacturing at next PCB. I think it's no-brainer. I'm here in a second. 1 minute. I'm back, and I have to finish this job. Okay, the capacitor is ready, and it should be near the V08 here, just to the ground. Yes. Yes. Okay. Not a biggie. Okay. And as I said in the stream description, Ethernet. Ethernet is here, and I think I don't have this symbol. I do. I do. Okay. So Ethernet. Here. Yes. So what size is 04? These 04, these 04, these 04, these 06, and these 04. Okay, this one. It's interesting that the 470 picofarads they use 0402, but 1 micro, which is like 2000 times higher value, is in a smaller package. Interesting. So 04 is the standard. The shield is directly connected to the ground, which is not correct. But this is the EMC. Okay, I probably use something slightly different. Oh, this one. Yes, this is the same one. From the, oh, where I am. Yes, so probably, maybe I've used it before. Oh, this is bus. Yeah. Okay. So let's go work on it. The same package. Yeah, probably yes. So VDD-IO 100 nano to 3.3. VDD-CR. Yeah, this is the strange combination of two. It's only, yeah. Yeah, I won't use this one. VDD1 and 2 here. So 10 micro and 210. So 2 pieces of this. Capacitor. 10 micro. Yes. Then there was a bead and 3.3. Yes. Okay. And this will have this name. Oh, this goes here. Yes. Okay. And we need. So I'm going like clockwise. So we need the 49 R9 resistors. I think I have these. Yes. So each. So this is the VDD IO. There is the ESD at each of them. Okay. So this should be here. Slightly different composition because my symbol is like diodes to the ground, and they know how to connect because they already did it. So TXP is input 2, RXP is input 1, TXN is input 3, yeah. Two capacitors. This is standard Mac jack. This one, yes. And this is still the local ground. Of course, what else could it be? Hmm. And the LEDs for the resistors for the LEDs. So LED 1 is yellow anode. LED 2 is green anode. Now the resistors from cathode both goes to the ground. I don't know if I have in the 0402. I will check. Similar value, it doesn't have to be the same. Oh, there are some strapping inputs. I don't really know if I can change the value. I think I can. But let's check the datasheet. Release. I think it's okay to change it to, for instance, 330 up, but I'm not sure. No, they mentioned 270. Okay. I will follow. This time I will follow because I don't want to make mistake because of my laziness. This one seems to be Yageo because I just to be sure if the part number exists, and I need just a PCB code. It does. So from both cathodes to the ground. Yeah, okay. And here, 1 mega ohm, 1K. It's oh, I'm sure. I'm sorry, 0. Yeah, this one. No, again, how big is this capacitor? Now I think 1 nano. I'm placing there already, always. 2K, this one. Yeah, this one. Yes. So this one. And 1 mega ohm. Yes. Yes, this is the optimal. Treatment of the chassis. CT is the VCC, VDDIO. Which should be there, here. Okay, so the right side is probably finished. Now the left side. Pull-ups. So I will copy it near my schematic to avoid. No, no, it doesn't work because I don't know where to connect. TXN. Is TXN. Ethernet 1 TX enable. Okay, that's better. Yeah, it's a name. Frankly, I have to say that I don't use buses, so I don't know how to connect the buses right now. I have to check it. So well before, okay. I always have to find a help. Bus, there are buses. Yeah, it's like the naming. Bus definition. Yeah, some spaces. Separate the signals of the bus. So we need a bus, for instance here. So the brackets. So they use this convention, okay. Ethernet 1, is probably the name of the bus in Altium. So Ethernet 1. How to define the bus? I'm such a idiot when talking about buses. I think it should be label, but it's such a long time. Last time defined a bus. Okay, so let's try. So let's try A and B. Something like this. How to check it? Yeah. And if I extend this to C, yeah, so it take the signal from the definition. So the definition is correct. Yeah, so probably I'm correct. So this will be only this. And TDO, TD1. No. Yes. And now if I create this like a bus, no members. Yeah, because understand, it doesn't know what are members. Yeah. So it seems that there always must be a I would like to see some manual. Bus members. Groove bus. Bus alias definitions. Schematic setup, okay. Okay. I can create alias Ethernet 1 and I can assign TX DO TXT1 and TX underscore enable. Yes. So this is my bus. No members. Why? Oh, probably I have to place it inside of, yes, makes sense. Yes, now it works. So I have more. RxD0, RxD1, GRSDV, MDC, MDIO, unreset, MD in MD INT, and clock. Okay, so this is our bus, and the signals are here. Okay, so all this goes here. I want the correct length of this piece. Oh, this one. This works differently. Yeah, and it works better. So now I can unfold from the bus. TXDO here. The label. Yes. You have to place the label first. And then the wire. CRS, no. CRS, yes. MDI. MDC. Reset. Interrupt is MD_int. And clock. This. I don't know why it's highlighted now. Okay. XTAL2 is unconnected. RXR is 10K to ground. 0201, 0402, and CSR is distributed. So, and here reset has 2 incorrectly exported registers because the pull-up is unpopulated. Okay, so reset. Will be handled here. So this is reset. We said that RXR is the same to ground. All grounds must be. same length. So we have 0 ohm in the reset and interrupt. Reset and interrupt. I'm just checking whether, yeah, all are populated. The 10K from the anode is unpopulated. Let 2 let's do LED 2 has unpopulated resistor to ground. Back we have 33 to TDO, TD1 and CRS, and Xtal is 22. So Xtal 22 and we have the same but 33, yes, but needs to be corrected because and I need this. Yes, it works. And I need no this, but this. And the same footprint datasheet. So here is our library item, datasheet, Yageo code 1% and GLC code, double checking 105. Perfect update. Great. And we said that it's in the RDO, RD1 and CRS. Yes, and there are 10K pull-ups. We have to add these descriptions because they are probably important. Okay, the pull-ups. How many? 5 pull-ups from RxDs, CRS, MDIO, and interrupt. Okay. So 1K, 10K. Yes. So 5 of them. And RxDs, CRS, as I said, CRS and DIO and interrupt. CRS, DIO, and interrupt. Yes. And all of them are 3.3. In the, yeah. I just wanted to say that in the PCB layout phase, I can connect it to the 1VDDIO or similar bus because it can be closer. So we'll learn how to define a special global bus. Oh, and reset is not part of the bus. Why not? Oh, it's part of the bus. Okay. Okay, I received a notification from my calendar that in 15 minutes I have a call. So I said that today we will work on PMIC. Next time I will check it, but I think it's okay. Pull-ups, serial registers, buses. Here the resistor RXR. Yes. R bias is missing. Here. It's a 12K1. Yes. Yes, I have only this one. So let me create it. I can use a combination of 12K and 100 ohms, which is something I did before. But in this, I think rather size constraints design, every single package footprint is better to save space. This, and what are the values? This is our favorite super duper register data sheet, order code, supplier, and JLC PCB code. Just double checking. 852, perfect. Great. This should be here. Okay, just a quick check. Looks good. Next time I will review it because we need it. Okay. I think I was productive, definitely more than last time. Code name is to be defined still. Okay, thank you for being here. I'm going to prepare myself for a call. See you next week, probably. I hope so. Have a nice day. Bye.